A force is a force or pull, and it is required to change the state of motion of an object. The scientific unit of force is in Newton. The net force of an object is a combination of all forces acting on it. The net force on an object changes its motion. Example: when you are holding on a rock and rest your hand, its net force is zero because you are pushing upward on it as much as gravity pulls it down.
So this is a video of Haley. So the push on the backpack is a force.
A force diagram. A force diagram is visual representation of all the forces acting on an object. The dot in the center of the diagram represents the object, and the arrows show the forces.
So different kinds of forces. Tension is a stretching force. Weight is the force of gravity acting downward on an object. The support force, or normal force, is the upward force that balances the weight of an object on a surface. For an object to be at rest on a horizontal surface, the support force has to be equal to the object's weight.
The support force on the snow globe is equal to the weight of the snow globe because the snow globe is at rest.
So this brings us into mechanical equilibrium. So equilibrium is a state of no change. Mechanical equilibrium is a state in which no physical changes occur, or a state of steadiness. When the net force on an object is zero, the object is in mechanical equilibrium. This is known as the equilibrium rule and can be expressed as the sum of the forces equals zero. So the symbol, it's like an E, stands for the sum of, and F stands for forces. Thus, EF equals zero means the sum of the forces is equal to zero.
When only one force is acting on an object, it cannot be in equilibrium. An object can be in equilibrium only when there are no forces acting on it, or when two or more forces acting on it combine to zero. Objects at rest are in static equilibrium. Objects moving at a constant speed in a straight line are in dynamic equilibrium. Static equilibrium and dynamic equilibrium are two types of mechanical equilibrium. Because both types are when an object is in a state of steadiness, no physical changes are occurring.
So like the snow globe, this stuffed animal is at rest. So its support force is equal to its weight. This means that the net force is zero, EF equals zero, so it is in static equilibrium.
Considered as a dynamic equilibrium because it is moving in a straight line at a constant speed, and the push is equal to the friction between the floor and the whistle, meaning the net force is zero.
Julia is at rest in static equilibrium because the tension in the rope is equal to her weight. Weight.
It like falls out.
Can you watch it again? One more time. Oops. How do you go back?
Oh, good question. You might have to go back on the computer. I'm sure there's a way to go back on the smartboard. I just don't know what it is.
I don't know how to do it again, sorry.
Can you hit play from the computer? There we go.
It falls out. The chinchilla falls out.
So it's not a mechanical equilibrium because there is a non-zero net force and it is not moving in a straight line.
So applying math to the equilibrium rule. So I'm going to explain it and then I'll do it on the board. This is just a practice problem. So a painter stands on the middle of a board that is suspended at the ends by two vertical ropes. The painter and the board are in mechanical equilibrium. The tension in each rope is 350 newtons and the painter's weight is 550 newtons. What is the weight of the board? So, here's the board. We know the tension in each rope is 350 newtons. And we know the weight of the painter is 550 newtons. So we can use EF equals 0. So 350 newtons plus 350 newtons minus 550 newtons, because weight is downward, minus the weight of the board equals 0. So 350 plus 350 because 700 minus 550 equals 150. So the weight of the board has to be 150.
A vector is an arrow that shows the magnitude and direction of the quantity. A vector quantity means magnitude and direction. Example, of course, is a vector quantity. A scalar quantity can be described by magnitude of, for example, time,
Area.
and volume.
So this brings us into the parallelogram rule. The parallelogram rule is to find the resultant or the sum of two or more vectors, make a parallelogram in which the two vectors are adjacent sides. The resultant is a diagonal of the parallelogram.
If vectors are in parallel lines in the same direction, they add.
So one's 5 newtons, one's 4 newtons, you can add them to get 9 newtons. If vectors are in parallel and in opposite directions, they subtract. So one's 5 newtons going to the right, one's 4 newtons to the left, so you would do 5 newtons minus 4 newtons equals 1 newton. And that's simplified.
The parallelogram rule is used to find the resultant of two non-parallel vectors.
So if it forms a right triangle with the resultant, you can use, we all know Pythagorean theorem. So this is hard to see, but this is 10, this is 3. So 3 newtons plus 10 newtons, 3 newtons squared plus 10 newtons squared equals c squared. So 9 plus 100 is 109, then you get 109 equals c squared. The square root of 109 is 10.4, so the resultant is 10.4.
More studies for chapter 2, chapter 2 summary sheet, chapter 2 textbook problems, chapter 2 understanding checks, unit 1 roll call, unit 1 2.1 quiz, unit 1 blue sheet, and unit 1 practices.
And keep in mind that it got a little complicated because like the unit 1 test consisted of both mechanical equilibrium and I'm pretty sure Newton's first law, which wasn't what this was on, so it's also part of unit 2 because Miss Bell said it just got a little like,
Little overlap.
yeah. Good luck.
Where's
So-
Nico?
Does anyone have questions? Sam, question?
Not a question. But, well, it's not a question. Isn't the, like, E thing called
Sigma. Yep.
That's, like, not a sort of a function.
Comment. Angel?
And the weight of the board is negative or positive.
The weight is negative,
Mm-hmm.
so it's going to be, it would be negative. I'm not sure.
It'd be negative.
Weight is always negative, so if you signify something as being a weight, it's assumed that it's a negative, but it doesn't hurt to put the negative sign in there also.
Where's Nico?
I'm sorry.
That is not a relevant question.
Are you videoing us? Are you
Yes.
just gonna watch these? Wait, video me!
Okay, does anyone else?
No! I'm kidding!
Hi, Jill. Does anybody else have relevant questions or comments?
Good job! Except I couldn't read it.
I'm sorry.
All right.
That's not your